I'm Anil Kumar, and here is a very interesting question from the previous test paper. Let us have a good look at it. The question is, solve the equation and round your answer to one decimal place. 9 sine square x plus 3 cos x minus 7 equals to 0 when the domain of the function is between 0 to 360 degrees. Now that means you have to write answer in degrees, right? So we have a quadratic equation. Since the term 3 cos x is there, it's a good idea to write sine square x as 1 minus cos square x. So let's do that. So we get 9 times 1 minus cos square x plus 3 cos x minus 7 equals to 0. So that is how you can write this particular equation, right? Now let's open this bracket and simplify. So we get 9 minus 9 cos square x plus 3 cos x minus 7 equals to 0. Combine these constants, and I also prefer to keep the leading coefficient positive. So I'll take all the terms to the right side. So we have 9 cos square x, we'll change the sign, minus 3 cos x. If I do 9 minus 7, I get plus 2. I'm taking it to the other side, minus 2, right? That is, go through this step once again. I did a lot of things here, right? Now we'll factor this, and factoring means product and sum. 9 times minus 2 is minus 18, and we need sum of minus 3. That means 6 and 3, right? So the numbers are 6 and 3. Minus 3 means 6 is negative. So we'll rewrite splitting the center term. So we get 9 cos square x minus 6 cos x plus 3x cos x minus 2 equals to 0. Combine these terms. 3 is common, right? So 3 cos x is common. So we get 3 times 3 is 9 cos x minus 2. And on this side, we again get 3 cos x minus 2. We'll put them in brackets. 3 cos x minus 2 equals to 0. Now we'll take 3 cos x minus 2 as a common factor. We're left with 3 cos x plus 1 from the other side equals to 0. Now to solve this equation, either one of these factors could be 0. So we have 3 cos x minus 2 equals to 0, or we have 3 cos x plus 1 equals to 0, right? So we need to solve these two equations. And now when you solve them, you can write this as cos x equals to 2 over 3, that is 1, and here you get cos x equals to minus 1 over 3. Let's go one step ahead to figure out where the solutions lie. Now for the first one, since cos is negative, solutions lie in quadrant 2 and 3. For the second one, since it is positive, it lies in quadrant 1 and 2, right? Why? The reason is the rule, which is the cast rule, right? So we apply the rule. So we know these are possible solutions. So in any case, whatever the solution be, first step is to find the related acute angle, right? So we'll do this on the right side of this page, one by one. So let's begin by solving cos x equals to 2 over 3. So what we'll now do here is, as we said, we're looking for a solution in, first let's find angle alpha, right? So let's say this is angle alpha for us. So we say acute angle alpha equals to cos inverse of 2 over 3. And that is equals to, let's use the calculator, and I hope it is in degrees. So we have cos inverse of 2 over 3. 2 divided by 3, which gives us 48.18, so that's good. One decimal place, so I'll round it to 48.2. So we get 48.2 degrees. Makes sense. So that is one angle, which we have already got. Positive value for cos should be here, so the other angle is this one, which should be how much? 360 minus 48.2. So the x will be the other value, 360 minus 48.2, right? So let's do that part. So it is 360 minus 48.2, which gives us 311 101.8 degrees. So these are the two angles which we got for cosine x equals to 2 over 3. Let's now calculate for cos x equals to minus 1 over 3, right? Now in this case, the acute angle alpha will be cos inverse of 1 over 3. Alpha is acute angle, always positive value, correct? So we'll do shift cos inverse 1 divided by 3 within brackets will give us equals to 70.52. So we'll write 5, right? Rounding to one decimal place. As we had seen earlier, cos is negative in these two quadrants, correct? And what we found here is the acute angle, which is how much? 70.5. Doesn't look like, but that is what it is. Okay, so that is the acute angle, correct? 70.5. So what is the principal angle? So we'll write x as equals to 180 degrees plus 70.5 and 180 degrees minus 70.5. So these are the two angles which we get from the second factor, correct? So 180 minus 70.5, which is equals to minus is 109.5 degrees, and 180 plus 70.5 gives us 250.5 degrees, correct? So these are the two solutions for the second factor. Combining all of them, we get all the solutions, right? So the solutions for our equation round to one decimal place will be 48.2 degrees, 311.8 degrees, and then we have 109.5 degrees and 250.5 degrees. And these are the steps which you should follow to answer and explain your solution. I hope that helps. I am Anil Kumar. Subscribe to my videos and learn how to get good marks in your test. Thank you and all the best.